Exercise 5.1, question number 1, Roman number 1. Solve the following quadratic equation by method of factorization. This method of factorization is splitting the middle term, the one that we have studied in class 8 and class 9. Splitting the middle term. Let us see the first question. We are going to find out the roots of this quadratic equation by the method of splitting the middle term. Let us solve it. We have here x squared. Let me solve it like this. X squared minus 7x plus 10 equals to 0. Here the product of the number is coefficient of x squared into constant number. Coefficient of x squared is equals to 1 and the constant number is 10. So we have here the product is 10 and the sum is minus 7. Find out the prime factorization of 10, the product 10. Become 2, 5 are 10. This 5 plus 2 is equals to 7. So 2 and 5 can give me minus 7. So we are going to split 7 into 2. 2 plus 5 is 7. This implies that x squared minus 2 plus 5. Instead of 7, we are writing 2 plus 5 into x plus 10 equals to 0. This implies that x squared minus 2x minus 5x plus 10 equals to 0. This implies from the first two, take common x minus 2. Then from these two, you take minus 5 common, become x minus 10. 10 is 5 2s are 10, becomes 0. This implies that from these two terms you take common. The common is x minus 2, x minus 5 equals to 0. We multiply two numbers. This is one number and x minus 5 is the other number. We multiply two numbers and the answer becomes 0. In corollary number 6, one of the number will be 0. Maybe x minus 2 will be equals to 0 or x minus 5 will be equals to 0. This implies that x equals to 2, here x equals to 5. Hence, the roots are 2 and 5. Yes, I hope you can see this solution. I'm not going to explain. The next questions I'm going to solve is question number 5. Copy down in your notebook. Then I'm going to solve Roman number 5 again. Like 5, 6 is also there, but I have shown you the solution. You should try to understand by yourself. Here, let us solve this. Root 2y squared minus 3y minus 2 root 2 equals to 0. First, we find out the product. Find out the product. The product is equals to coefficient of y squared is root 2 and constant term is minus 2 root 2. Find out the product. Minus 2 into root 2 squared become minus 4. And the sum is equals to 3. Prime factorize this. 4. 2 2s are 4 and 2 1 is 2. Let me proceed. And in order to get minus 3 there, 4 minus 3 can give you, 4 minus 1 can give you 3. So I'm going to put it as, since the sum is equal to 3, I'm going to put it as 4 minus 1, which will become 3. So from there we obtain like this. Root 2y squared minus 4 minus 1 into y minus 2 root 2 equals to 0. This implies that root 2y squared, open the bracket, minus 4y plus y minus 2 root 2 equals to 0. This implies from these two terms, there is no common, so you need to modify. Root 2y squared minus 4 can be written as 2 root 2 square into y. You should remember that 4 is equals to 2 into root 2 into root 2, meaning 2 root 2 square, which becomes 4. So instead of 4, we are writing 2 root 2 whole square y plus y minus 2 root 2 equals to 0. From the first two, you take root 2y common, then there will be y minus root 2y means that here there will still be 2 root 2. Here you take 1 common, become y minus 2 root 2 equals to 0. This implies that from the first two you take y minus 2 root 2 common, then root 2y plus 1 is equals to 0. So after we take common, we obtain like this. Now, like corollary number 6 in chapter 2, you multiply two number and the answer 0 means that one of the number will be equals to 0, or the other is root 2y plus 1 equals to 0. This implies that y equals to root 2, and here y will be equals to minus 1 by root 2, which we rationalize it, become minus root 2 by 2 after rationalizing it. Hence, the roots are 2 root 2 and minus root 2 by 2. So likewise, like I solved question number 1, 5 and 6, your homework, the one that you're supposed to work out by yourself will be Roman number 2, Roman number 3, and Roman number 4. These questions you should work out. And the formula to use and about the books, whenever there is in the exercise, I'll explain it when the questions are solved in the exercise.